So, good morning, everybody. My name is Mai-Kristin Haugen. I'm the Communication Director here in COWI Norway. COWI Try is an international talent program. And we're going to do these presentations in English because we have a worldwide audience with us today. So the presentations is done in English, and later on today you will have the opportunity to ask your questions and have a debate in Norwegian. But the first transmissions will be done in English. So first of all, welcome to our CEO, Marius Veidal Berg.
Thank you. Good morning. And welcome to this very exciting day. My name is Marius Berg, and as Mai-Kristin mentioned, I'm the CEO of COWI Norway. And today we're going to talk about COWI Try. And COWI Try is a summer program for students, 26 students from Norway and Denmark. And the beauty of this program is that we get to pick the brains, the young, new talent. And that's very inspirational for me. We also try to make sure that this has a real impact on their career and also give them relevant working experience. So it's a good match, both from the students' side also from COWI's side. This year, the point of departure has been the Solihøgda Plussby and the Romerikesbanen Service Tunnel, where the students have been looking at new visionary concepts and solutions for mobility solutions, more sustainable mobility solutions. And the government actually earlier this year launched a program to use Solihøgda Plussby and the Romerikesbanen Service Tunnel as a testing ground for groundbreaking, technologically advanced mobility solutions for the future. In addition to that, I'm just back from the Arendalsuke, and for me, this COWI Try project is really relevant. It's really evident that it's relevant. And in addition to Per Sandberg, the talk in town in Arendal was all about climate, smart cities, urban development, innovation, etc. So it's a really good fit. So I'm really pleased with this program this year. We are spot on, in my opinion. Also, we wouldn't have a program if we didn't have the students. So I would like to thank all the students for their participation and the effort put into this project. So I'm really looking forward to see the results, and I think it's going to be a fantastic day. Before we listen to the students, I'd like to hand over to Janne Walker-Orka, who is the Market Director for Sustainable Urban Development and the Project Manager for Solihøgda Plussby. Thank you.
Thank you for the introduction, Marius. I have been looking forward to hearing the students' presentation today. In fact, all facts the whole summer, because we had a kickoff in the end of June, start of July, and I was very excited after that. But before we hear from the students, I would like to give you an introduction to. But before we'll hear from the students, I'll give you a brief introduction to Solihøgda Plussby and the background for the case assessment and this year's innovation project. Solihøgda Plussby is an ambitious environmental urban project aiming to change the future of the Oslo region. We have been working on this urban development project for more than 1.5 years. And it has really changed us to rethink how we develop future cities, buildings and mobility solutions in the new circular economy. Our vision is to create the first European plus city. It's a city that is planned and designed utilizing environmental and smart technology from the start. Our calculations shows that the city potential can accommodate 30,000 inhabitants and 15,000 jobs. Solhøgda Plusby will be the first European plus city. It will be designed with knowledge we have about climate change, technology, and how we can create zero-emission cities and societies in the future. The city will be planned with green and intelligence mobility solutions that will change our transportation needs and the way we live and travel. The Oslo region is one of the fastest growing areas in Europe. Bærum is one of Norway's most ambitious municipalities when it comes to green and sustainable urban development. Oslo is the greenest capital in Europe in 2019. We are a nation that works actively and takes responsibility to fight global climate change by investing and developing smart and sustainable solutions for our cities. Innovation Norway talks about the look to Norway effects. At Solhøgda, we have a unique opportunity to do everything right from start. We have a unique opportunity to create green smart city laboratory, developing the city and identify which technology and solutions that also can be implemented in the existing city. We have already transferred multiple of our groundbreaking ideas and learnings from the project to existing urban development and projects in the other cities. It is incredibly inspiring to work to establish something that most likely will become leading with green urban development, but also a preferred residential destination. Solhøgda Plusby also meets the increasing strong demand for housing in the Oslo regions. Solhøgda Plusby is designed to reduce wasted time on everyday basis, gives the people wonderful recreation opportunities through the future way of living. The next generation will have a completely different focus on emissions and sustainability, on which the way they live in their life with their values. The big challenge. At Arendalsuka this week, our Prime Minister, Erna Solberg, said that in 2030, Norway should be able to look back on the good and right choice we took today in 2018. How would you design a new city from scratch? Who's going to start building in 2025? That's a big challenge. Solhøgda Plusby, the Plus City, is designed with these 4 principles. The smart city, smart mobility and transport. The plus energy. Solhøgda is close to the forest and will be a destination for the recreation and will be based on circular economy. The mobility and transport system is based on everything you need within 5 minutes and will focus on pioneering autonomous public transport. No cars in the city, no parking in the streets. That means that we will give the street back to the people. We will create good urban spaces for the people. Solihøgda is located close to the Nordmarka. This is a cross-country heaven in the winter. This gives us an opportunity to plan the Plus City with no more than 200 meters to the green path and nature. I would like to thank all of our partners. We are really happy that you have shared your knowledge with the student this summer. We think it has been very valuable to the students and for us. Thank you very much.
Thank you, Janne. So, this is how we're going to do this. First group is going to give their presentation. And in front here, I have a feedback team. They will give the group feedback. Then group 2, and this feedback team will give them feedback as well. And that's how we're going to do this. Then you know the drill. The students, they are allowed 10 minutes each. And, you know, we are on a rather tight time schedule here today. So some in front here are going to give the students a signal. That's just to keep the momentum. When we're done with the 5 presentations, then we will just stop the streaming, and you will be allowed into the discussions as well. Okay? Are you ready? Yes! Group 1, you're getting ready? Good. Group 1, they've been asked to solve, or just prepare to get up here. The challenge they received was the future urban planning of Solihøgda, the infrastructure both above and under the surface, the hill. So welcome, Group 1.
Vil du klikke for mig? Hello. Hi, and welcome. We're Group 1, and my name is Lone. Next one. Yeah. All right. Throughout this COWI project, we got the opportunity to investigate how could technology and infrastructure for efficient transportation of people, goods and waste be organized in order to take up a minimum amount of space in the cityscape, and what would the ideal use of the released space be? In our report, we have worked with the North mythology concept. As an example, which you will hear about later, we have Bifrost. Bifrost is the name of the bridge connecting the realm of gods with the world of humans in Norse mythology. In our project, we have designed a combined public transportation tube and highway for bikes. It is intended to connect all of Solihøgda, which make Bifrost the ideal name. But first, Hedda will tell us about the master plan.
Yes, and this is the master plan called Asgard. I'm just going to take you through the main points of the plan, because traditionally cities have been planned for cars and other types of transit above ground. But we have tried to turn this perception of a city upside down and change the passenger transportation, the delivery of goods and the waste management, and put all these functions underground. So basically we have designed a city for pedestrians and bicycles. By placing all these functions underground, we have been able to create a lot more space for recreation and social and green areas. And the only infrastructure left above ground is a main route for emission-free and autonomous buses and cars, an express road for bicycles, and paths for slow-running bicycles and pedestrians. Because Communities with a good overview and proximity to nature is what attracts people to the villages, while cities have other benefits such as diversity of people, services, and access to a large labor market. So we have tried to combine all these qualities and blur the boundary between urban and nature. Okay, so in order to give the streets back to the people, the plan focuses a lot on social spaces and an environment where it is easy and rewarding to get around by bike or by foot. The neighborhood has a common meeting place to strengthen unity, as well as a variety of spaces for public and private green areas. The streets are also designed in order to provide a lot of options when moving around and function as social arenas. Concerning residents and workplaces, these are mixed together close to the center so that we can reduce the need for transportation. So basically we will live more dense and closer to work, as well as to a lot of other functions that you need in your everyday life, all within walking and biking distance. And now Tobias is going to introduce you to one of our solutions for biking through the city.
Thank you. Okay, so as Lone mentioned in the intro, our main solution for the transportation of people is called Bifrost. And Bifrost is going to be also the main transportation corridor around Solihugda. It goes around the city in a loop, and it should ideally go through all the cities, all the small centers, and connect all the neighborhoods, and should be placed in a way so that it's always within a reasonable walking distance. It's elevated above the street level by pillars. You can see here, this is the street level. This is Bifrost. And the pillars have integrated elevators that can take you up to the Bifrost with your bike. Some of the pillars will be used for some urban farming, which we'll get back to. And the pillars can also go down into the ground and connect Bifrost to a hyperloop connection between Solihugda and Sandvika, or even an underground road tunnel system if that's going to be implemented. So the public transportation tube, if you go to the next slide, is sort of like a metro. It travels in both directions, and it travels very fast and only stops on demand at the platforms, and it's automated. It travels in a glass tube so that you have a really great view of the city as you're traveling, and we would like it to travel in vacuum by magnets so that it can travel very fast and very efficiently, and this will also reduce noise and vibrations and maintenance on the train. And then above it, on the roof of the metro, or this tube, there is a bike path, an open, wide bike path, sort of like a bike highway. And it has sensors along the way that monitor the weather so that when it's raining or snowing or very windy or cold, it has glass walls at the sides that can slide up like this and connect at the top to shield you while you're biking. So it's attractive even in the winter, again with a great view of the city as you're biking very fast. And now over to Eline. Oh, you have one, okay.
The bike path is made from recycled plastic that lasts like 2 or 3 years longer than asphalt. On rainy days, the shield collects storm water, and the water is stored just underneath the bike path, as you can see in the illustration. During the winter and cold weather, the water can be heated, which will ensure that the bike path is not going to freeze. And the water will be collected in a storm water system, and it will be heated and generated from a combustion. The road for the self-driving buses and cars will have the same system and work in the same way. So the road won't the snow won't be laid on the road during the winter, so you don't need to remove it. It just does it by itself.
Yes, and for the released space, we thought about among other things, urban farming. And we thought that this is going to be, we're going to make use of all the newest technology. There's going to be stormwater collectors on the roof, which make sure that the fields are going to get the right amount of water. And of course, there will be the right amount of UV light that will be generated by solar panels. And last, we have introduction for our city. Caroline?
Yeah. So we decided to explore a computer game called City Skylines to see if it could give any added value to our project. First of all, City Skylines is a city simulation. It's similar to SimCity, and it makes you build, run, and modify a city. The game has some really cool features to it. For example, it lets you walk the streets from a citizen's perspective, so that you can really feel the surroundings in a different way. A key takeaway from the game is that it could be used as a tool for participation and in public participation and involvement by, for example, arranging workshops or contests. This was actually done in a Finnish city called Hämeenlinna or something, where they had this area they wanted to develop. So they made a map of with the existing city, and they left blank this area they wanted to develop, and then anyone could download the map and then build, on the empty area. So to end the presentation, we will show you a 30-second peek of our creation, and it might give you an idea of how it is to ride a bicycle on the Bifrost.
Wow! Wasn't this cool? You'll just be standing here, and I'll hand over the microphone to the feedback team. Who wants to start? Lars-Erik? Yes. Lars-Erik, by the way, he's the Business Development Director for Transportation within the Transportation Division. Please.
Thank you, Group 1. I'm really impressed of your work within this limited time during this summer. Okay. I think your master plan was very visionary. It's a lot of new ideas, and I also like the link to the North mythologies. That was really impressive. And in some parts here, I also got a flashback to the series Westworld in a very positive matter. In a positive matter. And I also found this not a solution only for Sollihögda. I can see that this could be a basis for creating new cities all over the world. So, but what I'm a bit curious about, were you all agreed during this work, or did you have some tough discussions?
I feel like we we agreed. I mean, we had some discussions because that's a part of the group work, and also we have different backgrounds, so we contributed with different things, and we have different takes on what the solution could be. Yeah.
So we had a lot of discussing, but not like, I wouldn't say tough discussions. It was yeah.
Without discussions, you're not able to move on either. So I think you need to have some discussions in order to actually get somewhere.
Yes.
Yeah.
Because when you are working in a place like COWI, you have to discuss all the time, because then you find the best solutions. Okay.
Yeah.
Thank you.
I think the Bifrost concept was quite interesting because you combined these tubes and the bicycle together. And as Lars Erik also mentioned, I see that could be also a concept in an existing city. Have you thought about that during the work, that this is not only for a quite new city, but also quite adaptive to an existing city?
Yeah, I think we saw it that way, that it could be sort of a general solution.
And I found also an element in the report that you haven't mentioned here, but the self-driving bikes. That was very interesting. Is that a concept that you have found elsewhere, or
no?
There
is anywhere. There's actually a Google self-driving bike.
Okay.
Okay. Yeah. So we came up with it, and then we found out that someone had already had the idea. But yeah, we would have like an app, and then you can order it, and then the bike can come, and you can get on it.
I will like that bike.
Yes, thank you for a very good and interesting presentation. I'm very fascinated about the Bifrost or boulder, that you have function in different levels. Have you had a discussion about how much space you can, or how little space you can use compared to if you're going to get thing the normal way? Do you understand the question?
We have calculated just the gray surfaces, like roads and stuff, and I think we came to the conclusion that throughout the whole city of Stavanger we could save 44% of gray surfaces by doing it like this.
Wow, that's a lot.
Yeah.
Very interesting.
We didn't have time to present the transportation for goods and waste as well, which we also put in the ground, and they're called Yggdrasil and Sleipner in the report. So that also frees a lot of space, of course.
Øyvind, you've been part of an innovation booster here in COWI as well. Do you have some reflections or comments to share with them?
First of all, if I just take what the presentation, what I see here is a super cool framing of it. I think it's a really good way of presenting and make us kind of hook things, aspects to that. So that's super cool. I think you've managed to come up with a lot of realistic elements in this report. Some of them are a little bit far-fetched, as you have written, of course, but it's not unrealistic. So that's really cool. You have transportation with the loop in a hyperloop, which is in progress. I hope Elon Musk survives the next few years. We have waste handling, which actually exists, which you have written about in the report, which is absolutely people are using today. The bike concept is perfect. So I think you have a well of ideas here that you have put together. So it must have been some kind of interesting discussions here. I would like to be part of that. But how have you? I think there must be more ideas. So, and I know from as Mai-Kristin's comment, it's a lot of ideas coming up on the table. And how have you been? Have you come up with ideas that has not been presented, that you kind of have not taken out, but you maybe afterwards think we should have brought it in? Any there that we could juicy parts that you could share with us?
We talked about using the Bifrost as a path for cross-country skiing in the winter.
Yeah.
but that conflicts with the shield that makes you
the snow. So
so we had to choose. So we went for the idea with the shields so that people could bike throughout the winter instead. So anything else?
I think we also talked a lot about how we would like the society to be. We would like that it's a different kind of people living there, and how can we invite everybody who's interested to live in that kind of society. And in the report we talked a lot about shared economy, and I thought that was very interesting. We thought it would be fun if you could rent a dog just for the day. So you share it, so you make sure it gets the fresh air every day.
Yeah. We were also discussing how much drones would be used, like for transporting people or things, and we ended up not using that so much.
Okay. Good. Thank you so much. I think it's worth an applaud. So far, very inspiring. We could see from their concept that it was a transportation solution there. Next group, they have looked into the service tunnel and have looked into the opportunities of how could we use this service tunnel between Sandvika and Solihögda. Group 2, you ready? Yes. Yes.
Hey, I'm Marcus.
And I'm Andreas.
We're going to hold this presentation. We have with us in group 2 Vegard and Asbjørn as well, and Ida, she couldn't make it today. We were told to investigate possible uses of the service tunnel for high technological transport solutions. I do this myself. Which button is it? This one. So originally it was planned for a railway stop at Solihögda, but the plans for this were discarded, and now the service tunnel for Ringeriksbanen goes about 230 meters below the surface. So we are going to investigate how we could use this tunnel deep under the ground for potential transport solutions. We have a small overview video of where it is going. My bad. Starts at Solihögda here, and it goes 200 meters under the ground, and then it starts going upwards, and it comes out of the ground and into Sandvika here. Yeah. So, this is a service tunnel. It should still maintain its original function. So we were trying to find solutions that were effective in bringing people from Solihögda and to Sandvika, while at the same time maintaining the function that doing service for the railway tunnel, as well as supplying firefighting opportunities and escape route for if there's any emergencies in the main tunnel. We'll also look at how we connect this solution to Solihögda and Sandvika, as well as we wanted it to fit in with the vision of Solihögda. We wanted to use the vision of circular economy and plus energy as well. And we have got two scenarios that we will take a look at: cable car and hyperloop. I'll give it over to Andreas.
Yes, so our first solution and idea focuses greatly on co-usage of the service tunnel. Its main purpose is originally to evacuate people in case of emergencies, and also for service by Bane NOR, who builds and services the tunnel. So we came up with the idea of combining the Easy Mile autonomous electric buses with something a bit more, something perhaps not so innovative, but reusing sort of old technology for newer purposes could be innovative in itself. So we have a cable car system, which is a cable embedded into the pavement of the service tunnel, which stretches the path going all the way from Solhøgda down to Sandvika and back up again in circle. And the buses connect to the cable and are dragged along. So we can achieve quite a bit higher speed than what they usually have. Those Easy Mile, which are shown in the previous slide, have a top speed of 45 kilometers per hour. We would expect at least 100 more for this system to be viable. And of course, being an electric vehicle, as most electric vehicles have, what they have is something called regenerative braking, where when you go down a hill, the car brakes, and by braking, it charges its batteries to some degree. So if we could combine that, the cable car system drags the bus, it also uses regenerative braking to charge the batteries. This means that they can go continuously without having to stop for charging at any point. Some of the pros behind this is that if they, as was mentioned in the introduction, there will be autonomous electric buses that will drive people from Solhøgda around. And with these buses, they could drive straight down to the service tunnel and pass passengers all the way down to Sandvika, and then take people from Sandvika and take them up again. Yes?
Yeah. Then we have the Hyperloop system. Hyperloop is a pod inside a tube, and we would like it to be as low pressure environment inside this tube to reduce the air resistance. We will combine it with magnetic levitation, maglev, to reduce friction from the rail up to the pod. And this allows for a system that theoretically could go between 1,200 and 1,300 kilometers an hour. Yeah, theoretically. We have two alternatives for this. First of all, we wanted to keep the original cross-section of the service tunnel, and we would like to fit everything inside the transport solutions at the same time as meeting the requirements for emergencies and escape routes. And there's another case where we wanted to maximize the mobility of the solution, where the Hyperloop could fit Easy Miles or autonomous vehicles inside it. This alternative, we had to broaden the cross-section or the dimensions. We'll take a look at that. I have brought some key numbers with me. From the Hyperloop Alpha, we got this. This is the requirements. It should not accelerate any faster than 1G, and 1G is a lot. We don't think that's very viable. And also the centripetal acceleration. This one we have actually used because there's the last turn into Sandvika is only a turning radius of 1,500. And we investigated this, and then this means that you need to keep a top speed at 300 kilometers an hour in this turn, which makes it a little bit harder. This is the first alternative, just a simplified sketch. We'll get back to what this water pipe and the fire robot is. We'll get back to it. This is number 2, where Easy Miles is inside. We had to, as you can see, the height is a lot bigger now. I should also say there's a Hyperloop in each direction. This is some of the main consideration, because from Solhøgda to Sandvika, it's only 13.5 kilometers. And you need some time for it to accelerate up to top speed. And there's a trade-off between speed and comfort when you have this short distance. So I just brought some key figures. We took the acceleration, longitudinal acceleration, a bit down to 1.5, which is still a lot. And as you can see, if you reach a top speed of 300, you would have a total travel time of 163, where most of the time you're in constant speed, which means it's comfortable. But if you increase it to 500, you will only get about like 25 seconds more travel time, and you reduce the amount of time considerably where you're in constant speed. And as an extreme here, you have reduced the travel time only like 9 seconds from 500, and only 12 seconds is in constant speed, which means that you're spending most of your time accelerating and deaccelerating, which is not very comfortable. You just sit there and yeah. So this is the trade-off when you when you have this short distance. So even though the theoretical speed is over 1,000 kilometers an hour, it's not viable at this this stretch. I'll give it over to Andreas.
Yes, so one of the issues is how we connect to existing infrastructure both in Sandvika and in Solihögda. As you can see here, we have tried to generate a picture where we have Sandvika station with a Hyperloop station placed above it. And in the next slide, please.
Yeah.
Here we have a model of the station at Solihögda. This is underground, about 200 meters below the surface. And for the next slide, let's see. We need some access to the service tunnel at Solihögda. To do that, we had two main ideas. The first one was to use what is planned as the escape route exits. That's the picture to the left from Bane Nor. And to the right here, we have an idea where we use a type of elevator, which has to be quite large, especially in the case if we wanted to use the alternative 2 of the Hyperloop, where we have the Easy Mile buses traveling through the Hyperloop in the service tunnel, or in the first scenario where the Easy Mile buses go down to the service tunnel. We have, there are some, as you can see, the small circles, one is shaded and one is not. That is a thought of using ballast.
Yeah.
And I think we have quite a few. We're using up most of our time, so we'll just. This is just
How
to.
are we on time now?
We're done.
Okay, blast through it.
Okay, so this is because of the Hyperloop. We are short on space, so this is an idea for a remotely operated fire vehicle.
Yeah. Okay, so this is quite important. We wanted to fit this in with the vision. So we imagine a sophisticated urban runoff system inside Solihögda, where all household wastewater and urban runoff goes to the same treatment plant. You could store the water in basins, and since this is a large height potential, pressure potential of over 200 meters, you could implement hydropower down to help power the Hyperloop, and leftover electricity could be sent back in the vision of plus energy. We also have a solution here for helping using vacuum. This is a simple Venturi vacuum jet, where you go from a large cross section, water flows down to a smaller cross section, and when it suddenly increases in cross section, you generate a vacuum, and there's a suction that could help suck air out of the Hyperloops. This could minimize the cost of maintaining vacuum in a Hyperloop. It could also help supply the firefighting, and also be used for cooling of machinery and other solutions. And we have a future consideration, but I think we'll just skip that, I guess. Sorry.
Get ready for the future. You know, amusement parks, nothing compared to Hyperloop. And I also must say that we have been trying to get in touch with Elon Musk. We've been tweeting with him or trying to reach him with the tweeters. But I think he's, he's rather busy with his own company these days. So, Lars-Erik.
Yes. Thank you, Group 2. I'm also impressed what you have been sorting out this summer. And I find this very realistic. It's not only visionary ideas, but you have been working and taking into account the formal barriers, like the service tunnel has a primary function, and you have taken this into consideration in your work, and that's very good, because I think Bane NOR has some thoughts about a solution like this. But also in a cost perspective, I have read your report as well, and the use of service tunnels wherever they are. The infrastructure is already there, and you can easily implement a Hyperloop system. But my question to you is, after working with this all this summer, do you believe in this? Is this possible?
Good. I have to say that I think there's a lot of issues with laws, politics, safety, everything. And what if it goes, let's say there's a vacuum inside and suddenly you have a hole inside it. What could happen, and what happens if your pod is suddenly experiencing turbulence or jerk or something like that? It's I don't think they'll find a solution in this before a lot of years.
No.
Or maybe you know better.
Thank you.
Yeah, I also think that was a good presentation. I like this more technical approach also to get us a little bit more understanding of the Hyperloop and how it interacts with the people traveling on it. So that was a strong part of it. So and I don't think we should exceed 300 kilometers.
Yeah, thank you. It's a very good presentation and lots of energy in that, really. And I was thinking about what you said, the realism here. If you consider we were inventing cars today, would we allow 2 cars to meet on each side 1 meter apart in 80 kilometers per hour? So I mean, it's a question of how you evaluate the risk. So I think I'm maybe more optimistic than you on this. When it comes to did you ever consider that utilizing the tunnel and the transportation in combination with evacuating people?
Yeah, we did. If we go a bit back, is that allowed?
On slide.
Just these cross sections, because we used the requirements. Oh my bad. The requirements for evacuation is 125. It's not on this one either. Here you can see. The requirements for escape route is 2.25 in height and 1.4 in... So we've taken that into account and made the pillars of the Hyperloop fit that. And the fire robot is also very small, and you would have a lot of them. And we didn't say that we wanted to have like some what's it called, caverns, bergrom, for maintenance equipment that's stored there permanently.
And could anyone enter the Hyperloop on the way, or could they enter any other transport system here to evacuate the people stuck in the system? I mean, Bane NOR, I guess, would like to get people out of the area. That was the question. Did you consider that? No.
We try to consider that, but one of the reasons why it's elevated the Hyperloop, it wouldn't really need the pillars if we could use the tunnel as a tunnel. Yeah. So fitting a vehicle for transportation might be a difficult task in these scenarios, or the second scenario we had. For the first scenario with the easy mile buses going down, we can utilize almost all the space by just having the buses move to the side, and they could even be used for evacuation purposes.
Exactly. Exactly.
Being autonomous, they could be programmed to be. Yeah.
Yeah. Very good. Thank you.
Okay. Fine. Thank you so much.
Thank you.
So, group 3, are you getting ready? Yes, they are. And they asked the question, could Solihøgda become the first city where people living there don't really feel the need to own their own car? So, here you are with some microphones.
Hello, I would like to introduce myself. My name is Tadas, and these are my colleagues, Johannes, Per, Eirik, and Ole. And throughout the summer, we were trying to solve a problem. Could Solihøgda become the first city where people feel no necessity to own a car? To develop an insight and to know what are the challenges, we try to make strengths and weaknesses charts to know what are the strengths and weaknesses of owning a privately owned car. So by doing that, we managed to start generating ideas how to implement all the strengths of owning a private car to the public transport system, however, excluding the weaknesses. We managed to come up with several solutions, and the first solution will be presented by Eirik.
Yes, so Group 2 have been dealing with transportation out of Solihøgda, while we have been dealing with the transportation inside the city. And we have come up with a solution with communicating autonomous buses. And what are autonomous buses? They are self-driving and without a bus driver. It's not a new idea, but it's been tested this year by a condo. But we are planning to take it a step further with artificial intelligence. So the buses, they should monitoring the transportation need in the city and then travel to where the transportation need is the most. And after we have seen on the autonomous buses, there was another problem that come up that Per Christian is going to talk about.
Okay, let's talk about motion sickness. It's a problem. We all recognize it. It's called bilsyke or båtsyke på sjøsyke in Norwegian, and it's a real problem. And a lot of people experience motion sickness a lot. To keep the biology story short, it's caused by a conflict in the brain between the senses. When the balance feels something and the eyes see something else, then the brain shuts down and says, we're poisoned and we're going to be sick. And there is expected a huge increase in motion sickness when the autonomous cars takes over, because no one drives the cars. And the driver usually doesn't get motion sick. There will also be a possibility for intoxicated people and kids to drive around, which get motion sickness easier. Today, there are no perfect solution to the problem. We have no perfect solution. The picture on the top here is just a few weeks old. It's from a CNN article. It's the car company Citroën who has made those glasses, which are going to give the eyes stimulation according to the movement of the car, and it's supposed to work. But let's agree, they are horrible. They look really, really bad. So we have made a solution which, if it's viable, we think is way, way better. And then we really want to, instead of giving the eyes the simulation, the simile of motion, we want to give the balance nerve the simulation that it doesn't move, that you're standing still even though you're in a car. So using audio or vibrations, maybe even from the car seat, we're going to send adaptive waves into you in according to the car's motion, which will neglect or reduce the feeling of motion sickness. So yeah, it's like active noise cancelling, but for motion instead of noise. That's the plan. And now, Ole, you have one.
Yeah. Okay. This is an expansion of today's bicycle rental service. But instead of only having one type of bike, we want to have different bikes for different needs. For example, the three you see on the screen. One regular bike for just traveling, one bike with a seat for small children, and one cargo bike for carrying goods, furniture, or passed out friends. But the most important part is that the bikes are available. If you have used the bicycles here in Oslo, you probably have noticed that most are either full or empty, for example, on top of a hill or at the bottom. So as Eirik mentioned previously, we want to use the AI buses to redistribute the bikes between rush hours. And
I mentioned it.
Yeah, so they'll know where the bikes need to be when people want to travel. So you'll never have to bike around and look for places to park the bike, or yeah, vice versa. Johannes is going to tell you a little more about how a regular day will look like using this transportation option.
Yep. So we started wondering how a typical day for an inhabitant in Sølihøjda would look like. And since the city will provide around 15,000 jobs, we assumed that some of the inhabitants will work within their own part of the city. And this cycle shows you how you'll be able to conquer the daily challenges of transporting using the city cycle principle. So taking a closer look at the cycle, you will start in point 1, where you will walk outside your home and choose the bike that fits your needs on the specific day. Then you will change the bike as your needs change during your way. But what if you worked outside your part of the city, or maybe even in a different city, like for example Oslo? The circle, as you can see, is more or less the same. The only difference is we added another step in the bottom called the mobility center. And at the mobility center, it could, for example, be an autonomous bus taking you somewhere else within Sølihøjda, or it could maybe be a different kind of vehicle. And Tadas will try to give you an overview.
Here you can see a simplified master plan of 2 neighborhoods connected via mobility center. And we were considering that in order for our solutions to be feasible, we need to have compact and bicycle-friendly city design or infrastructure. This could be considered as one of the possible solutions for the infrastructure. We also considered what needs to be done in the future, and these parts will be covered by Ole and Johannes.
So you may think now that we talked with group 1, but we didn't. We actually came up with the idea of bicycle highways. And one of the challenges with biking and walking as well in larger cities is the flow of your biking. And most bikes will probably be electric in the future. And since these electric bikes give you the opportunity to go even faster than you do today, the bicycle highway can change the flow of biking since you're able to avoid typical stops, like for example a traffic light. This will, of course, increase the speed of biking and save time. Another thing is the weather. And the bicycle highway is, or the weather is maybe one of the most important factors when you're going to choose between a bike or vehicle. And the bicycle highway will be able to provide you shelter from bad weather. And since Sølvhøyda is in Norway, this is a very current issue. So by providing shelter, the bicycle highway will increase the comfort of biking. And Ole will talk about another future consideration.
Yeah, as you may see, this idea is not yet fully developed. But the main point is that instead of having the buses redistribute the bikes, we want the racks to be able to move around and pick up and deliver bikes all over the city. And this means that they also can move to hotspots where the need is especially high for bikes. So, yeah. Any questions?
So, thank you so much for that. So, here we have the feedback group.
I think the bike ideas is quite good here. I would like to have a bike that's changing during my day, so I think that's a good idea. Of course, it will be a lot of logistics to have this. Will you combine it with some types of sensors telling the systems where people actually is?
So actually the idea of the bike rack, for example, could be that it's AI controlled as well. So the bike racks would know which bike is needed or which type of bike is needed. Yeah.
Yes, thank you for a very good presentation. Yeah, I'm wondering about you have lots of how the bicycles are going to work with the AE buses and that. How have you discussed how you got people actually to use it? How are they going to? Is it behavior going to change for people to use this and actually believe in it? Have you had that discussion?
You can see on the master plan, it's not allowed to use a car in the city.
Okay. Yeah.
So people have to deal with another option, and it has to be comfortable and it has to be fast. So the thing with a car today is that you can just go out the door and sit in the car. So with the AI autonomous buses, they should know they don't have fixed routes or fixed schedules. They should just know where the need is.
Another thing which we were considering that there will be parking restrictions, so it would be faster to travel with bike around the neighborhood than actually to have a car. But well, in this master plan we didn't show the parking spots, but in general we were talking about that the neighborhood would be free of cars, and if you want to park a car you need to put it away from, not away, but outside the neighborhood.
Yes, thank you for your presentation, and I liked a lot of your technical solutions, especially about artificial intelligence, that autonomous vehicles talking to each other. But also that you got more into the disadvantages with new technology, like the motion sickness. We should be aware of the disadvantages that new technology will create. But it's almost the same as Janne, because I also read your report, and I think you write some of it there, because it's not only about the technology, but the human touch. Changing attitude and changing behavior, going from car to other more environmentally friendly vehicles. So I wish you could present some of your thoughts here in your presentation, because you have written it in your report. So if you have something to add about that.
Okay. The thing is that the initial idea was to make a alternative traveling methods as comfortable as having a car. So while we were discussing, we were thinking that this is one of the most convenient way to still keep the personal space and to save time.
And that's the bicycle highway. Did that come up from the question you asked that people should?
Yeah, that came up. The thing is, when you're riding a bicycle, the weather conditions are really essential. So if it's raining or snowing, usually people tend to use other means of transportation. So by implementing bicycle highways, we're capable of sorting this problem.
It's very good combining in your group work, both new technology and the human touch.
Yes, we were considering these factors also.
Thank you.
Final question, reflection from Øyvind.
Thank you. It's very, very interesting. I think a lot of this is realistic again. And super interesting with this moving vehicle to move the bikes other places. I think you have an excellent starting point because you look at the strengths and weaknesses with regards to what are the concerns with regard to changing from car to other vehicles. And you're meeting that gap. You're looking at that gap to how we're going to do that, and that's a very, very good start. So, and I think you've achieved something there. And using artificial intelligence in this concept, it's kind of almost obvious that you should do, and I think it's absolutely realistic. So maybe it's already done, for what I know, in some cases. Overall, very, very interesting, and I think it's realistic what you're presenting, actually. Yep.
Thank you.
I have one question, Christine, if it's okay. Did you think about other vehicles than bikes? Because we have heard about bikes, but there are a lot of other funny transportation methods like segways and so forth, which is possible, and electric driven, which could be used here.
Yeah, I actually looked at wheelchairs, and in winter it's possible to use skis, right? So I have like a city rental skis. But yeah,
I think we talk about like electric longboards. They're also here, and segways and stuff like that. But I mean, it can be implemented in the bike racks. It doesn't have to be a bike.
Yeah. So just a comment. It would enhance the report in that case that you actually mentioned that, because it's a lot of funny transportation methods these days that you see people running on one-wheelers and so forth. So it's yep. Yeah. But it's otherwise it's very good.
We had a document with crazy ideas, and Ole made a wheelchair like an egg, so sealed, and we had it wasn't really feasible.
Don't say that.
Never shut down a good idea. Thank you so much. So for those of you that have seen the short form MAAS, Mobility as a Service, this is a part of this. So have you heard about upcycling? Anybody heard about upcycling? No? Well, if you haven't, Group 4 is going to give you an introduction.
Thank you for the introduction. So first off, my name is Emilia. This is Alan and Rasmus, and we also had Jonas on our group down there, and Annette, but she couldn't be here today. Okay, so we all know that the population of the world is increasing, and so are the needs for different resources, such as food, water, and raw materials. But the problem is that we don't have enough. And Solihögda knows this, and that is probably why we were given this case. So again, how could we build an upcycled city from low value to high value resources? And our answer to that is circular economy. Circular economy is a way of thinking that challenges us to find solutions that allows both processing and use of local processing and use of different raw materials, so-called waste and other resources. Yeah. From the construction of the tunnel under Solihögda Plusby, there will be massive surpluses of rocks. And the challenge is, instead of just driving these massives away or deposit, we have to use them locally. The challenge has been to find new or extend the areas of use and find solutions that allows local processing. In the running phase, we need to make use of so-called waste, such as rainwater and food waste, and that is also a challenge we have been looking into. Now we're going to present some of our solutions. In order to maintain a zero-emission building site and the profit of local use, we have to process the masses locally, as I said. And you cannot just go and build a new processing facility anywhere you start a building project, so the solution would have to be a movable facility. But this, today, movable facilities is really expensive, and the return of investment is really slow. So what we need is a new technology that allows us to make solutions that can make cheaper facilities. Also, the facilities has to be cheaper to produce and easy to move around without affecting the capacity. Yeah.
Like Emilia said, we would like to increase the demand for using these surplus masses. And we are focused on recreational spaces and to increase the quality of living in Solihögda. At the same time, we would like to utilize rainwater and stormwater in the area. And to solve this, we were inspired by there's been built skating parks in Oslo where the skating parks is combined with handling and managing stormwater. And we have extended this idea into a system of recreational areas and parks. And they are all connected with waterways between them throughout the city. And this system is supposed to handle both short-term management of heavy rainfall and also long-term storage of water in order to have a stable supply of water for drier periods. So we have pictured many different recreational areas, but one main element here is amphitheater that we imagine being built at a central location in the town. We have talked about taking the cars away and giving the streets back to the people, so we are also going back and looking at some old ideas from ancient Greece. This amphitheater is able to store water. We see that there's a stage here, and underneath the stage, which is raised on columns, you can store large amounts of water. The water is planned being used for vegetable gardens, which Rasmus is going to talk more about later. But we also have talked about other uses where you don't need the high-quality drinking water, because today we use high-quality drinking water for every purpose, but maybe for flushing toilets, watering plants, you don't need the same quality of water. We can see a short video here from showing the amphitheater, if it works. Here we see rainwater coming down, and we can also connect existing waterways in the area into our system. And here is the amphitheater, where you see the kind of like pool underneath the stage. And there is also an output of water here that goes into other areas of the town. And here you can see a vegetable garden, which is served with water from the amphitheater. The next slide is a map of Solihögda, and it shows how we think this can be implemented. The blue lines are the waterways through the city, the green dots are the vegetable gardens, and the purple ones are the different recreational areas and parks. We think that the water, running water itself, is a positive element in a city. It makes the parks better, and it's a good element. Yeah, and the number of parks and gardens can be adjusted, but our idea is that it should be easy access to these areas everywhere in the city. Yeah, Rasmus.
Yeah, this is one of our other ideas, which you can see it's a lot of small gardens, which is gathered in larger communities. So the idea is that it should help circular economy and help get the whole mentality of using local goods rather than getting stuff that has had a lot of transport. So in the idea, we thought that each small slot could be rented by a family or just someone owning an apartment in Sollihögda, and then they could grow vegetables in them for food consumption, much like a sports club. The difference between this and rather than just doing it back in our own garden, which a lot of people would have the ability to, but they're not doing it, is that here they could meet a few times a week. Maybe like growing the vegetable is a boring chore, but if you meet up a few times a week and tend to your garden together, it might be a fun thing to do. And then you could use like in the middle of the community as a recreation area. Then we would like to have these gardens placed close to densely populated areas, just so that people's everyday waste could use to make compost, which could be used as fertilizers. A big part of this is getting the locals engaged in it, because if it's not a good social place, people are probably not gonna spend a lot of time on their garden, and the productivity is not gonna be very high. Another thing to consider is the size of each slot. It will vary on how much is reasonable, how many vegetables each family should produce a year, if it should be their whole consumption, or if they should just cover some of it, and then they could buy the rest in supermarkets. Then, as at the video, you could see that we had animated the greenhouses as the green gardens as a greenhouse. So it has to be considered whether it should be a greenhouse or more as an open garden, which would be more easy to make from surplus masses from the infrastructure. Yeah, and yes. This has been our presentation. We have really enjoyed working in COWI Try, where it has been a great addition to our everyday work, where we usually do theoretical work. This has been very innovative and more thoughtful work. Thank you.
Thank you so much. Any feedback for the team? Who wants to start? Jørn.
I like the idea of the multi-purpose installations. Have you and of course the amphitheater. Have you considered any other ideas of the same way to have things being for functional, for technical installations, and also for use of people?
One of the things we thought about was using some of the surplus masses to make a wall to reduce noise from construction area, because it will be a work in progress thing, constructing Sollihögda.
Yes, thank you. It's very interesting to read your report and also listen to your presentation. Actually, the innovative thing for me was the sports club analogy to gardening. I've never heard about it. It might be done somewhere else, but it's actually a super interesting concept. So maybe I'm out ignorant here now, but that's all right. And the combination of amphi and water, gardening and so forth is really cool. and absolutely realistic. But the whole topic of upcycling and circular economy is super serious issue, and we need to think about it, and such ideas like this is important. So, but did you come up with any other things that you maybe you didn't bring in here, but that could have been brought into the report, or and so forth, that you turned down for some reason?
We wrote a little bit in the report about a leasing concept, where it's not related to the mass thing, but it's about leasing furniture. Yeah. That people should not own furniture, but they should borrow it instead, so that the stores can take back the products and reuse the materials for new furniture, for example. We didn't bring it to the presentation, but it's in the report, I think. Yeah.
I remember when I had met you in Lyngby, when we had the kickoff, and we had a very wide discussion in ups and downs, and lots of good and not maybe so good ideas. What have been the most, what have been the funnest part of the COWI Try in all the discussions?
Well, when we met in Lyngby, we tried to think about how can we use surpluses masses in a whole new way, but that was really challenging, because it's stones. How much can we do with stones? How innovative can we be? So in the beginning it was hard to come up with new ideas and innovation things, but we tried to just think, okay, maybe if we combine others old solutions with some new concepts, that could be innovative. But yeah.
I think you've done a good job from combined the amphitheater, the skate park, the water and the rainwater, and the rocks. So good work.
Yes, thank you for your presentation. And it's always a challenge with the surplus masses in the huge infrastructure constructions. So I liked your your ideas, and especially the amphitheater with also a water storage. And our experience this summer, we need water storage for dry periods. Yeah? So if your ideas that you presented now, if they will be realized, I really think Sollihögda and Bærum kommune, Bærum municipality, could be an example in Europe for upcycling, and that your presentation showed us. But did you discuss any barriers making this realistic? What prevent us to do this?
We discussed people's mind and holdninger to this topic.
Attitude, yeah.
Yeah, they have to change the way we think of ownership and be able to I don't know.
Yeah, just the whole mindset of recycling and taking care of what's around you. Yeah, and then the whole mindset of constructing a city where it's more, we like to build more very dense. I live in Copenhagen in a very densely populated areas, and there's very little green areas, and so it just creates much of I buy stuff and consume and throw them out, and that's something we might have to get rid of and try to produce stuff ourselves.
Yeah.
Thank you.
So thank you so much. So now it is actually just one more group to go. And they have been asked the question, how can Sollihögda Plusby contribute to Bærum municipality's vision of becoming a zero-emission community? So I'm really looking forward to this, and I hope everybody from Bærum listen in.
Yeah, we are group 5. My name is Marius, and I have Christian Fredrik, Christina, and Fredrik. And we also have Oda, but she couldn't make it today. Our problem statement is how can Sollihögda contribute to be Bærum's zero emission goals or become Europe's first plus city? We have 4 solutions to this. We have 2 solutions for the plus city, 1 solution for the zero emission, and 1 solution for the city as a whole. And now Christian will start presenting the first solution.
Yes. Okay. Yeah, our first solution aims at helping Sollihögda become a plus city. And when making a plus city, we really have to consider making use of all the energy sources you can find in your surroundings. And in Sollihögda, there will be hills and steep landscape. And we wish to use this for our benefit. Our idea is to utilize the kinetic energy from the wastewater running down the hills in order to produce electricity. And this will be done by just tweaking the sewage system that already have to be built. So this is our solution. When the wastewater is collected from the households, it will be first brought into a heat exchanger where we wish to utilize the heat from the sewage system and bring the heat back to the apartments. Then the water will have to be cleaned, so it will go into a treatment plant where the sludge is filtered out, and this sludge can be used in a combustion plant to be transformed into biogas. And this biogas can then be used as energy to be used on cold days when there's high demand for energy. Next, the water will run down the hill, creating kinetic energy. And this is where we'll be using Kaplan turbines in order to transform the kinetic energy into electricity to support the energy grid of the city. But also, we wish to use some of this electricity in the process of electrolysis, where water molecules are split into oxygen atoms and hydrogen atoms. And this hydrogen can then be used as emission-free fuel for the buses and cars of the city. At last, the rinsed water will just run off into a lake nearby.
What's important when creating a plus city is using the solar power. I want to do that by PVT panels, which is a combined solar panel with a thermal solar collector. And this we want to build in the entire city, in the building and the roads as well. And we also want to use something called transparent solar cells in the windows to use the window also as an energy source. And what we see here is a PVT sidewalk. And what's special about that is it's pressure-based and using the kinetic energy from the humans walking. And then this will be transformed into electricity. And then you can use the electricity to just light up the sidewalk when humans walk into it. So that's quite innovative, we think.
Okay. When we recycle, we convert old materials into new products. And by this, we reduce the need to consume raw materials. As well, we save energy. Our idea is that we have a shaft, a waste shaft, that is integrated in every household, where all types of waste is thrown in. This waste will be transported under the ground to where this sensor technology will sort out the waste, and the waste will be put into different pipes for further transported to recycling units. And these units have their own production center where new products are being made. And also, we want to kind of make people be more aware of sustainability and their own waste production. We propose 2 features that comes with this shaft. Firstly, we have this weight that is integrated in the shaft, that will weight your waste every time that you put something waste in it. And this will be a computer tablet that will be integrated in the shaft, as you can see here, that will give you the monthly waste that you have, and also show you the average waste in Sollihögda. And this will encourage to waste less. And also, we want maybe that you can order new products from this tablet. Yeah, and this is waste shaft, sensors, recycling stations, order new products. There you have it. And by this, you simplify your waste management, and recycling will no longer depend on us, but it will be taken care of by machines.
Oh, okay. Yeah, so now we're zooming out a bit, looking at the city as a whole. We would like to boil all these good ingredients we now have summed up, and even more. So by boiling all this, we know as a home kitchen, we get this bouillon. And that's what we want to call this neighborhood, the bouillon neighborhood. The idea of the perfect neighborhood. We believe to create a city, and that's what we call a plus city. So by looking at these different neighborhoods in Sollihögda, we take a unit and call this neighborhood the Bouillon neighborhood, and by that we define both the local community, the technologies, and of course the nature. We have so talk about this kind of combined neighborhoods. We talk about the scale. How do we define the scale of these neighborhoods? We talk about seeing and the way we live as a completely new way of living as we do today, combined in the future. So we have to change the way we live, basically. Defining these technologies, as summed up in this presentation, there are a great deal of examples. Also other things such as like satellite downstreaming and new materials based on nature. So to sum up, we basically want to change the way a city works, inspired by nature, as nature works in spirals, and this organic transition. We take Sollihögda with these neighborhoods. We see that they all are transforming energy, and through the smart grid, we have the nature in the center, and it's developing continually to, as nature always improve itself to be stronger. So to survive, we need to be the strongest, and therefore Sollihögda will be this organic paradigm of the spiral-inspired system. Yeah. So by saying that, we believe that Sollihögda is a strong city. And also we would like to thank you guys for this opportunity, and we'll now go to the questions.
Thank you. I'm looking at the feedback team. Are you ready to give some feedback to the group? Who wants to start?
Yeah. Yes, thank you for your presentation. This Bouillon neighborhood seems interesting, and it's could maybe be a bit chaotic, but with further development it will probably be okay. But I asking about, or first, I like the PVT panels on the sidewalk and the waste system. That was very good. If the solution on the neighborhood is going to be easy for people to use, Have you talked about or discussed how easy it is to implement in real life the ideas you have?
Yeah, I can just take this. We have been looking out for how could this work, for example, with the waste shaft system. And there's new technology that, like these sensors, that will have been, actually I think Sintef has been researching these sensor technologies that will sort out waste by sending light through, and the reflection will tell you if it's either plastic, paper, or even gas. So I think this might be a solution for this, and also as it being so simple, that will encourage people to maybe try it out.
I have something to addition there. The PVT panels exist today, but the scale that we, I think, in the buildings and roads, that's something that's never been done before. And we have an assumption there that we need the cost for PVT panels to drop a bit before we maybe can do this.
And also, we have to investigate like the composition of this PVT roads and how like the big weight that is putting on it. That's also something that should be investigated. Yeah.
Transport.
Yeah.
Okay, thank you. Very interesting, and compared to the other groups, your solution, especially regarding the waste shafts, we are not dependent on people's attitudes or behavior. So that is a barrier for all the other groups, but not in this case for you. And I have to admit that I need some more time to understand this bouillon and organic paradigm. But have you invented this, or is it based on?
Well, I have to say that we are not the first to talk about this, and of course the bouillon is just a narrative to explain that when you design a neighborhood, you cannot put everything in it, but you need a high diversity. You need a palette to, when you talk about an ecosystem, you need a high diversity to make it work. And when designing a new city, when you look around the city today, you see great examples, but also bad examples, and we need to look at the bad examples to understand, like, how do we define what can be the new city. And as we are trying to explain through our report as well, this palette of different things, technologies combined with our social aspects and the economic part as well. So we have this sustainable loop, which is very important when you look at, because how do we define a neighborhood? It could be difficult to define, but if I should define my neighborhood, it should be the place I were the most, right? It could be work, or it could be my school. But what if it were my home? Like the place I lived, then they talk about the move from the sphere. Yeah, so there's a lot of thoughts into this.
I will definitely read more about this.
Yeah.
Thank you.
Yeah, I think you're combining quite well-known technology into a more new whole. And I think it's quite interesting to see that you're taking advantage of the elevation at these systems. So I think it's quite realistic, some of the ideas and the concept. So I liked it.
Do you want a final comment, Eivind?
Well, it's been said a lot here now. So, but I think the concept of maximizing and collect energy is where kind of maybe the core realistic thing here. But did you ever consider the magnitude here, the numbers, or what you could gain here, and how you could possibly store energy?
Yeah. We want the entire city, the energy to flow in buildings. If a building maybe have excess of energy, and then a building at the same time of the day which have a need of energy, Then we've seen how smart grid solutions and microgrid solutions can optimize this energy flow between buildings. So that's been a part in the report, so I consider that a lot.
Thank you.
Thank you so much. Give them a hand.